Okay, in this tutorial we are going to solve question from 2020 chemistry, question number 3. And the first question, which is question A, reads: a coefficient and subscript on the symbol of nitrogen atom mean different notation in chemistry. A coefficient and subscript on the symbol of nitrogen atom mean different notations in chemistry. What is the significant difference between the two notation, the coefficient 2n and the subscript n2? So what is the significant difference between these two notation? So the significant difference is that in 2n means two atoms of nitrogen are together, while n2 means two atoms of nitrogen are bonded to each other. So this means in 2n you just have two atoms of hydrogen which are just closer to each other. Maybe they are packed in the same container or a beaker or wherever. But n2 is referring to a nitrogen molecule where you have your two atoms of nitrogen bonded together. They are sharing electrons. Okay? Then the second question say, draw the dot and cross structure showing outer shells only for the two notations. Draw the dot and cross structure showing outer shells only for the two notation. Okay, so they just want us to illustrate using the cross and dot structures using the outer shell. So before we go to the drawing of the outer shells, we can do the electronic configuration for nitrogen for us to know how many shells will be in the outermost shell. How many electron I mean will be in the outermost shell. So we'll follow the duet and the octet rule. So we always know that the first shell will observe the dual rule, which mean which simply say there must be two electrons in that inner shell. So for nitrogen, we know that nitrogen has got a mass of 14 and the proton number of 7. So the innermost shell will contain 2 electrons and the outermost shell will contain 5 electrons. So in our outermost shell we are going to have 5 electrons. So back now to our question. The first notation, just as we answered in the first question, to say we just have two nitrogen atoms which are closer to each other. They are not bonded to each other. So we are going to have something like this. A nitrogen atom here, with 5 electrons. So 1, 2, 3, 4, 5. Okay. Then another one here with again 5 electrons. So we have to follow the instruction. They said we have to use dot and cross. So if in the first atom you used a crosses to indicate electron, make sure in the second one you use dots, or vice versa. So this is the orientation in the first notation. Then we go back to the other notation which says N2. So this means two atoms of nitrogen, they are bounded to each other. They are bonded to each other. So we're going to have this kind of an orientation like this. Okay. Then since each of them had 5 electrons in the outermost shell, now and they are bonding. We know that when atoms bond, they want to fulfill stability. They want to achieve stability by having 8 electrons in their outermost shell. So this one, each one of them need 3 to be stable. So it means in their sharing, each one will donate 3. So this one will bring 1 electron, the other one will also bring 1 electron, the other one will bring another one. Okay, let me draw something big. Okay, okay. So this one will bring an electron, then the other one also bring, the other one will bring, the other one also share, the other one will share, the other one will share. So each one will donate 3 electrons because each one is remaining with 3 electrons to be stable. So where will each going to acquire the 3 electrons from? They can only achieve that by sharing. So each one of them will donate 3. So we have 3 dots and 3 crosses there in their intersection. So since this one donated 3, the remainder will be 2. So we are going to remain with 2 here. Then the other side again, this one donated the 3, so the remainder is 2. So we are going to remain with 2 electrons here. Okay, so let us count now the configuration for individual. So this is 1 2 3 4 5 6 7 8. Even this one again, 1 2 3 4 5 6 7 8. So each one has achieved stability. So this is the orientation they wanted you to show when they said show this kind of notation in drawing. Okay, then the second question, which was question B, said both carbon tetrachloride and potassium chloride are compound of chlorine. Compare the electrical conductivity of liquid carbon tetrachloride and liquid potassium chloride. Okay, so if you see the compound we are comparing, there is carbon tetrachloride. This means you have a carbon and 4 chlorine, and there is potassium chloride. You have your potassium bonded to chlorine. So in simpler term, they just want you to compare the electrical conductivity between a covalent and an ionic compound. For a covalent compound, you have 2 nanometers or 3 nanometers or so on, which are just sharing electrons equally. Then for an ionic compound, you are going to have a metallic and a non-metallic element, where a metallic element loses electron and a non-metallic element gains those electrons. So from the two, we can see that carbon tetrachloride is made up of 9 metals only. So this is a covalent compound, and potassium chloride is an ionic compound. So now when you are comparing the electroconductivity, it is well known that ionic compound will conduct electricity faster than covalent compound. So in short, we just say potassium chloride have high conductivity than carbon tetrachloride. That's all. Then question number 2, which of the two compounds has a higher melting point? Explain your answer. Which of the two compounds has a higher melting point? Explain your answer. So we always expect an ionic compound to have a high melting and boiling point than a covalent compound. So from the above statement, potassium chloride will have high melting point. So the reason is due to high or strong electrostatic forces of attraction. Forces it would take more temperature to break the bonds which are existing in potassium chloride as compared to the amount of temperature required to break the bonds which are existing in carbon tetrachloride. The reason is due to the strong electrostatic forces which are existing between atoms of potassium and chlorine. Okay.